All right, I guess we have covered a lot of theory in our previous video. Like we talked about a lot of stuff like the history of DeFi, AMMs, how order books came in, how it went away and then came back with Injective's help. So all those kind of things like we talked about in depth. Now I guess it's time we get started with the coding and see how everything works in code, right? So yeah, so that's what we're going to do today. So I'll just give you a brief idea of what it is that we're trying to do. So let me just create a walkthrough.md. I mean, it's just, you don't have to create it. I'm just so that explaining, I can explain things better. So okay, so what we're going to do is we are going to create an automated trading bot. Okay, so that's the agenda. So, in order to help you understand all these things, what we're going to do is we are going to build an automated trading bot on the Injective protocol. Now, what's really cool about this is that it's going to be a smart contract that can actually place orders on the Injective's decentralized exchange completely autonomously. Right now, when I say automated trading bot, I wanted to understand that. I mean, I really mean it in the context of blockchains and smart contract. Like we are not talking about a Python script running on your laptop and which connects to your API, right? We are talking about a smart contract, right, that lives on the injective chain. Okay, we're not talking about creating another script, right? And this code, which is all the properties of a smart contract, right? It's immutable, anybody can come in and verify. And the cool part is the code or the contract can actually execute trade without any centralized servers or infrastructure, right? So this is actually a fundamentally different paradigm from traditional trading bots. And when you think about it, it actually opens up a lot of possibilities. Like you have smart contracts doing trades for you, right? So now, and one of the major parts of the puzzle, like when you are building this whole thing, one of the biggest parts of the puzzle is something called as precompiles. Now, if you have been following along with our previous video, you already know about Injective's precompile because we already discussed about it in our last video, which was released on day 9th of like 30 days of solidity challenge. So you can just check in October 9th. Like you can go to the Web3Compass YouTube and check out the video on October 9th. It's about injective, precompiles. Like there is a whole video on it. And in that video, we actually use something called as the bank precompile, right? So yeah, so precompiles are basically like the secret sauce that makes everything work. So so the thing is, for those who might be jumping in fresh or need a quick refresher, like let me give you a context of what makes this whole thing possible and why is this actually kind of a big deal, right? So the thing is, from our like since we are building a trading bot, the ability to build a trading bot as a smart contract isn't something that you can do on most blockchain, right? Even on Ethereum, which has like a massive ecosystem, like DeFi ecosystem, you typically can't have a smart contract directly interact with the core, exchange functionalities of a DEX in the same way that we do here or that we are going to do here, right? I mean, with your typical smart contracts in Ethereum, you are usually limited to calling other smart contracts that implement token swaps or liquidity pools. But Injective via these precompiles, it gives you something that's much more powerful, right? And that's what we are going to leverage today. So in our last video, we had a long discussion about precompiles, and so I mean, for those who are new, let me break this down because it's a really important concept. That actually is kind of a USP of Injective as compared to other blockchains, right? So like traditionally, when you're working with Ethereum or other EVM chains, your contracts are pretty limited in what they can do. Now, by that I mean not on the coding side, but the amount of complexity that you can do with the code, right? The amount of functionality that you can incorporate with the code. I mean, they can of course transfer tokens, they can call other contracts, they can store data, but I mean, let's say we want something deeper. Like even in Ethereum, they use precompile. Okay, like for example, like if you want to interact with deeper protocol level features of the blockchain itself, maybe some cryptography, maybe you have to do some core cryptography or verification or something like that, right? So if you want to do something that involves such core complex functionalities, you're out of luck, because your smart contract lives in this sandbox environment where it can only do what the EVM allows it to do, right? So that's generally how it works. So Injective, what it did is it actually introduced these precompiles. Again, it's not something Injective started. Like, precompiles are there in a lot of blockchains, even Ethereum. You can check out the previous. Again, I keep shilling the previous video, but we actually talked about this, and I think we actually showed a couple of precompiles that are there in Ethereum. Okay, so what are precompiled? So the thing is, like, based on the name itself, you get a general idea, right? They are precompiled contracts. Okay, they are also contracts, but the thing is, it is not one of those contracts where you deploy every time you want to use it. They are precompiled, and these are special contracts that already live at a special address or a fixed address on the blockchain. Okay, like, you can just go to the documentation. Oh, wait, sorry. There is the yeah, okay. So yeah, you can just go to this Injective doc, which talks about it. It's like highly optimized smart contracts embedded directly into the EVM. Now you know that Injective is EVM compatible. That's why you are able to run Solidity, right? So these are like special smart contracts that are directly uh, you know embedded into the core blockchain. Okay, so these things, like, they have a fixed address, right? Like, our next standard Solidity smart contracts that are deployed by users, precompiles are part of the chain's core logic itself. So it's not something that you deploy every now and then. Okay, it's already embedded into your chain, or the core logic of the chain, right? And they sort of act as these bridges between your smart contract code and the chain's native module, like in our case, Injective's native module. So you can think of them as like these official APIs that are built directly into the blockchain itself, right? The ones we are going to work with today, it's called the exchange precompile. Okay, we already did a video on the bank precompile, and today we are going to talk about something called the exchange precompile. Okay, so which so the exchange precompile, it sits at the address OX65. Now this is the address, and this address is fixed. I mean, if you access this address, you are basically accessing the exchange precompile. Okay, now this address never changes, and it is basically same across all the Injective networks. Okay, so today, like, let me just write it down. So in this video, we are going to, these are like special contracts that are embedded directly into the core chain logic, right? And today we are going to use something called as the exchange precompile. So this is a special contract, and it basically, you know in Injective, both in testnet and in the mainnet, it lives in this particular address. Okay, so this exchange precompile essentially exposes all of the Injective's powerful exchange functionalities, directly into our smart contract. So we don't have to write anything in order for us to trade a token, or whatever, do any kind of exchange functionality. We just have to talk to this precompile. Okay, and I mean, like, you can do a lot of stuff, like, place limit orders, market orders, cancel orders, manage something called sub accounts, which we will talk about, query market data. So all of this stuff that you would normally have to go through a separate interface or API, or some SDK, you can do it directly from your Solidity code. Okay, so that's what's really powerful about it, right? It's not some kind of wrapper around an external service. I mean, this is direct access to the same exchange engine that powers all of Injective's trading, right? So when your smart contract places an order through the precompile, that order goes into the exact same order book that all the other professional traders in the Injective network is using, right? So it's basically you are tapping into a production level code or a production level engine that powers the entire trading infrastructure of Injective, right? So that's what make I mean you know since you have all these features already pre-compiled into a contract, I think that's what makes building a trading bot as a smart contract pretty straightforward when you think about it. I mean, you're not trying to hack together some workaround or build a complex system of off-chain components. You're just writing Solidity code and you just call a couple of functions on the pre-compile, right? And those functions do exactly what you expect them to do. Okay, so it's really simple in a way, right? Like since you already have all these codes set up in the precompile, it's pretty simple. So I mean, let's just go ahead and talk about the approach that we're going to use. Like what are we actually trying to build and stuff. So let me just do approach. Okay, so today, I mean, we're talking about the kind of thing that we are going to do, and the thing is, we are deliberately taking a very simple and beginner-friendly path here. Okay, and that's actually a very conscious choice because, like, let's say, like, okay, we'll be building. Okay, so yeah, just give me a second. Okay, so we will be building a simple trading bot contract. Okay, so that's what we are going to build today. A very simple trading bot contract, and like, and I mean it. Like it's going to be super simple. Like we want this thing to be something that someone who is relatively new to this whole smart contract development can understand and deploy. Right? Actually, without using any or getting overwhelmed by any complexity or stuff. I mean, there are ways we could make this sophisticated. Like it's a trading bot, right? So you can always add more features, get it more, make it more optimized. You can do all those kind of stuff. But that's not the goal here, right? The goal is to create a solid foundation. So it's pretty straightforward what we are going to do. So you are the user, right? You will deploy our contract, and you will fund that contract with some injective tokens. Fund with Injective, right? So, and then the contract can place and manage orders on the Injective spot market on your behalf. Okay, the contract is actually owner control, meaning you control it. I mean, the person who deploys the contract can control it. You can tell it what to do. Nobody else can come along and use your contract to place orders or withdraw your funds. But once it's set up and funded, it can execute trade automatically based on your commands that you give it. Okay, you call a function, pass in some parameters, like which market you want to trade on, what prices, what quantity, and the contract handles all the details of actually placing the order on the exchange. Okay, now for doing all that, we are also using something called as sub accounts. Okay, now sub accounts. Okay, so yeah, I mean, this is also a really elegant way of managing trading balances, and you can. I mean, this is pretty cool stuff because once you understand it, you can understand how the whole system works. So the thing is, like when you look at how everything works, like typically, like when you do trading, you have a main wallet account, right? Like where you have all the coins and tokens and whatever, right? So the thing is here on Injective, like trading doesn't happen directly from your wallet address. Okay, instead you have these things called sub account. Okay, a sub account is basically like an offshoot account, or it is like a trading account that's associated with your main address but separate from your main wallet balance. Okay, so you can have multiple sub accounts, each with their own balances, and you can move funds between them. I mean, this might sound complicated, but the beautiful part is every contract automatically gets a default account ID. I mean, sub account ID, right? So you have like when you look at it, suppose you have a contract address, so this automatically gets a sub account. Since we are trading using the contract, this our contract will automatically have a sub account. Okay. Now, and it gets a sub account ID, and the thing is, this whole sub account ID or the identification for this sub account is actually derived from the address itself, like the contract address itself. Okay, and the thing is, it is deterministic, meaning for every contract address there is a very deterministic way to actually find out the sub account IDs, meaning it is calculated using a formula based on the contract's address, so you can always figure out what it is. So, and the thing is, any fund you send to the contract address are automatically available in the sub account for trading, right? You don't have to manually deposit or withdraw between accounts. You don't have to call any special function to move your money around. It just works. Send some injective to the contract, and the contract can immediately use it to place the orders, right? So, and the contract itself, like our contract itself, will also expose a lot of cool functions, like place spot limit orders. There can be functions for canceling orders, maybe ways to check the balance and get information about the contract status. And we will also build in some emergency features like pausing the contract in case the bot goes crazy. So all those things will be embedded directly into the contract, right? So this is the general thing that we're going to build today. And yeah, so for doing this, what we are going to do is we are going to use something called as hard hat. Okay, so hard hat is also a solidity development framework. And yeah, let's just, before we start building, let me just talk about it a bit, so that you're like, in case you guys are new to it, let me just give you a quick introduction of what hard hat is. All right, so hard hat, much like Foundry that we used in our last video, is basically an Ethereum development framework. Right now, one of the things that I like about Hard Hat the most is that it is like, in Hard Hat you write everything using JavaScript, or yeah, basic JavaScript. So you don't have to. You can either use JavaScript or TypeScript, but I think JavaScript is one of the most popular languages, and all you need is Node installed in your system. Like, so, I think it works just fine for all Windows or Mac or Linux system. All you need is Node.js, and it works, right? So yeah, as you can see, it's basically an Ethereum development framework, and just like any other, popular frameworks, it comes with all the tools and gadgets to help you test, help you deploy, help you interact with your contract, right? And I think a lot of people. I think Hard Hat is actually one of the most popular, frameworks that people use to build stuff. And like I said, it has a lot of cool toolkit. Like, it has a comprehensive toolkit that can handle everything: compilation, testing, deployment, everything. And since Injective is EVM compatible, all of these toolings just works. I mean that's actually one of the huge advantage of Injective's architecture. We don't have to write a whole new set of tools or anything. Like, since the whole thing is EVM compatible or built on top of EVM, all the mature battle tested tools that Ethereum developers have been using, it works perfectly on Injective too. So and the thing is, like, we can configure hard hat to point to Injective's RPC endpoint, and we can basically, use that to deploy our contract and interact with it, and everything. So in our project, we'll set up a bunch of contracts, and we'll set up a bunch of scripts, and scripts which includes one for deploying, one for funding the contract, one for calling the uh, place order function, and all those kind of things. So for all that, we'll create script, and also we'll create the contracts that we will actually deploy. Now, yeah, so that's pretty much the basics. Like, we can just go ahead and get started with hard hat. But before that, like, since we are going to work on Injective, I'm pretty sure you guys already know this, we'll be interacting with the Injective testnet. So make sure that you have the Injective testnet details added to your MetaMask account, so that you can keep track of all the faucet tokens and stuff. Like, I have already added it, but if you want to, you can just go, I think, network information. Yeah, just go to the Injective docs, network information. You can, yeah, go to this. Yeah, there you go. So there is the main net, and this is the test net. So you can just add all these details. Okay, so you can just go to MetaMask, click this networks, add custom network, and add all these details. So I've added all of them. So it's yeah, it's pretty cool. So yeah, that's it. And once you have these things, what you have to do is just go to the testnet faucet. There are a couple of faucets like injective testnet faucets available. There is this one where you just have to paste the address. Just copy this address and paste it here, and prove that you are not a robot. And oh wow, it is actually giving me a test. What is this? Okay, okay, whatever. So yeah, just click on request tokens. Oh, okay. So I've already, yeah, of course. Now there is a much more generous token also, which is called. You can just go to Injective Google Google Faucet. This is a way more generous faucet, which gives like 10 testnet tokens. You can also check it out. You just have to, okay. So for this, you have to get the injective address. Okay, just place this and you will get your injective address. So copy this and you have to paste it here. I mean, I've already, I got like 10 injective tokens. So yeah, right. So yeah, I already have these tokens, but yeah, it is much more generous because we get 10 tokens. So yeah, make sure you have the tokens, and then we can just go ahead and set up our project. So let me just resize the whole thing. Okay, this is better. Yeah, save it. Open a new folder. Integrated terminal. I'll just create a new folder, and I'll just call it market trading bot. Yeah, let me just cd into it. And yeah, to set up a hard hat project, like I said, all you need is you need to install Node.js. So just go to the Node.js website. It's pretty simple, like and it works across platforms, right? You just have to download it. Like if you are using whatever, like Linux, Windows, Macs, whatever, Mac OS, whatever, you can just install it, and yeah, then you can go ahead and install Hard Hat. So once you have Node in your system, just go Node minus V. I think it's better to use a version greater than 22.10, like version above 22. It can be the latest. I think latest is around 24, but yeah, use something that's about 22, 22 or above, right? Don't use 20 and stuff. Okay, so yeah, then what you have to do is just type in npx hard hat init. Okay, so this will initialize hard hat. So I'll just go for the older version. This is the path, and yeah. So a mocha with ether.js. So ether.js is a library that helps us interact with the RPC nodes and stuff. So we'll just set up a basic JavaScript project using Mocha and ethers.js. And Mocha is a testing framework. We won't be using a testing framework for this one, but yeah, I mean, you can just select that. Uh, and the best part is it will just install all these different libraries, right? Like a lot of these we won't be using all of them, like chai and ethers we will, but yeah, we will be using some of these libraries, but yeah, it will just install everything, so it's fine. And if you go to the folder, you can see that we have a basic project structure setup. You have the contracts, you have ignition. I'll tell you what it is, but you have the test. But I think, yeah, I mean, for this, since we're keeping it simple, you can just delete the test and ignition. We'll just use contracts, and we'll also create another folder called scripts where we'll write all the scripts. Yeah, so that's basically it. And one another really important thing that you have to look at is the hard hat config.js. So as the name sounds, this is the command center or the control panel of the project, right? So for any configuration that is in your project, you need this, like for any and all configurations that you have to set up, like whether it is adding setting up the test networks, setting up the compiler version, whatever, you do this in the config.js. like we will do it, like I'll show you how to do it once the whole thing is installed. So yeah, so this is like we have already set up our basic project structure. Now once the whole npm packages are installed, we'll just go ahead and configure our projects and start writing our contract. So yeah, let's go.